Hi, and welcome back to the e-learning video series on BSF biowaste processing. This module in the BSFL conversion chapter will focus on the harvesting stage. After watching this module, you'll be able to describe the process parameters of this stage. You'll also be able to apply the harvesting procedure, including the preparation of the harvesting station. Then, you'll be able to identify the correct mesh size which is used for the separation of the different material sources. Lastly, you'll be able to recognize the need for certain data and apply the procedures for the collection of this data.
The aim of the process in the harvesting stage is to obtain the larvae fraction from the treatment crate. They are currently still mixed in the residue though. To ensure that the larval fraction is as pure or clean as possible, we have split this operation into two steps. The first is a mechanical operation where you will see how the material from the crates is added into a hopper, and from there it is transported on a conveyor belt into the sieve where the material is mechanically separated into three fractions, which we'll be talking about more in the next slide. The second step is the manual separation step. So we notice that although we try to get a larvae fraction as pure as possible, we always notice that residual particles, of which diameter is similar to that of the larvae, remain in the larval fraction. This remaining residue has to be manually separated, and the larvae are helping us with this. How? Well, because the larvae have the tendency to push up material that they don't feed on, which is the residue, because it has no nutritional value for the larvae anymore. As shown in the figure, the separation stage will be fed with the material from the conversion units, which are ready to be harvested, and we'll separate this material into three fractions. The first fraction, which comes out on the top of the sieve, is the coarse residue. This material mainly exists of particles that could not be shredded into smaller pieces and that were also not fed on by the larvae, and thus the material kept the shape it had when coming out of the shredder. Materials regularly found in this fraction are hard organic materials like seeds, pits, or skins from fruits, woody materials, and remaining inorganic materials which were not sorted out. The second fraction, which will come out in the middle of the sieve, are the live larvae. The live larvae are still mixed with small amounts of residue that have a diameter which is similar to that of the larvae. The third fraction, which comes out on the bottom part of the sieve, is the fine residue, and we also call this frass. This is the excreta of the larvae after processing the biowaste. Notice that for the three layers, there are different particle sizes that are allowed, and these relate to the mesh size of the sieve, which are 3 and 7 millimeters. So on the top, all the residue is bigger than 7 millimeter. It stays there because the mesh size there is only 7 millimeters. All the material that is in between the two layers of 3 and 7 millimeters, on the bottom, everything is smaller than 3 millimeters because it has passed through the mesh of 3 millimeters. Then, after the mechanical process, there is a manual separation process, where the larvae and the small amount of residue with a similar diameter as the larvae are separated by removing the top material which the larvae have pushed up, as I explained to you previously. The coarse residue from the top layer combined with the manually removed coarse residue are composted. The fine residue, or the frass, from the bottom layer is directly bagged in plastic woven aerated bags and separately composted by just adding water on top of the bag every 3 days. To learn more about the composting process itself, we recommend you to watch the EWAG MOOC course on municipal solid waste management in developing countries. As with the previous modules in this chapter, what you see in front of you are the materials that are used in our pilot site. They're of course too big to be positioned in our studio, and that's why we cannot show you all of them. First of all, we use a conveyor hopper system together with a mechanical vibro sieve. The conveyor with the hopper is custom made, and the vibrating sieve system is a Guangyu GY1002S version. It has dimensions of 100 x 100 x 106 centimeters, a 2 horsepower dynamo with a voltage of 380, which is a 3-phase connection, and it runs at 1440 RPM. We use bins for material storage. Ours are 80-liter versions to collect the different materials that come out of the outlets. we then can move these materials around using a spade. We can weigh the crates on a bulk scale with a max capacity of 150 kilograms and accuracy of 50 grams. And we can move around bins and crates and the scale using a trolley. We start the operation by preparing the harvesting area. We will show you a small setup, and we will focus on showing you the different residue streams and how they look, so that you can identify these different residue streams and compare them to what you see in your own site. In the further operation, we then select the pallet or pallets that will be harvested on this day by checking the setup and harvesting schedule that you currently see in front of you. And we move these to the harvesting area using a pallet trolley. We then take the first 3 crates with a mixture of residue and larvae from the pallet and place them on the sieve. We note down the mass in the log sheet, and we then empty the 3 crates one by one into the hopper so that the material is gradually transported by the conveyor belt onto the top of the sieve. Here we show you what you can expect the different streams to look like, which will come out of the sieving machine. We repeat this process of each batch until one complete pallet is harvested. While harvesting the pallets, make sure you keep the 3 output streams of one pallet separated from the other pallets. One output stream will have larger particles. The content of this bin is weighed, noted down, and the material is composted. Another output stream is the fine residue. The content of this bin is weighed, noted down, and the material is then bagged. The third residue stream are the larvae, which are still mixed with some residue, with a particle size similar to the size of the larvae. The residue is removed by skimming this off by hand from the top of the bin, as larvae are pushing up the residue. After no clusters of the residue can be seen in the bin with the larvae can be weighed and the weight can be noted down. So the operation that we just went through, as you can see in the checklist in front of you, was split up into 2 steps. The first step was the pallet harvesting or the mechanical harvest. We there moved 1 pallet to the sieving machine, following the pallet setup and harvesting schedule that you found in the treatment module. Then we placed the buckets under the 3 outlets of the sieve. Then we turn on the sieve machine and the conveyor. We turn on the bulk balance and then tare the weight of 3 empty crates. We then took the first crate, weighed it, and noted down the weight before emptying those 3 crates into the container hopper and repeating this process for all crates on the pallet, while replacing the full buckets under the outlets with the empty ones, making sure that all the full buckets of one pallet were kept separated from the other pallets so that we can measure the data separately. And we then repeated the process for the other pallets that we have to harvest. Then for the manual sieving step, the second step here, we removed the particles that were pushed up by the larvae from the top of the bin with the larvae in it. We then weighed the larvae, recorded the weight, and repeated this for the other buckets of one pallet with the larvae, and repeated those steps then for the other buckets of other pallets that we harvested. There are 2 data recording steps in this operation. The first one was the pallet harvesting, where we measured and noted down the weight of the crates of one pallet that we have manually separated the residue of. And we noted down the larval weight after removing the residue part from the top of the bucket. For the harvesting process, we have 2 tables in our performance control log sheet that we can fill in, which were related to the 2 points of data collection. The first table concerns with the weight of the crates. You can see in front of you that there is space to fill in the codes of 3 pallets. So you can harvest up to 3 pallets per day using this log sheet. And for the example, we fill in 1 for you. So first of all, you fill in the pallet code on the top, which in this case is P3. And then you fill in the crates with each batch of 3 for 1 cell. They were placed on the third bulk balance, so it's only the material weight. So you can see the weight of the batches of the crates fill in the table. And then, using a calculator, you can note down the total weight of the material in one pallet. The second table concerns with the data after the manual separation, where you have a larva fraction and you have a combined weight of all the residue fractions. The sum of these 2 values should be the same as or similar to the sum of all the materials that were harvested from this one pallet. We are nearing the end of this module. Here are 2 questions to refresh your mind. First, what are the 3 fractions which are separated by the sieve? They are the fine residue, or the fraise, the larvae, and the coarse residue. Second question. What is the purpose of the manual separation step? The purpose is to remove residual material with a particle size similar to that of the larvae and thereby further purifying the larval fraction output of the sieve.
We've already come to the end of this module on the harvesting stage. You learned about that the harvesting step comes before the conditioning step and after the treatment. You learned that the BSFL are separated from two fractions of residue, the coarse and the more finer fraction. And you learned that the data on total amount of harvested larvae and residue is necessary to be collected to support the performance indicator points.
Thank you for watching this module, part of the e-learning video series on BSF biowaste processing. More information can be found in the BSF step-by-step guide, which you can download through the QR code here. Both of these materials were part of the Forward project by EWAC, in collaboration with the Ministry of Public Works in Indonesia and funded by SECO, the Swiss State Secretariat for Economic Affairs.